From modest and humble beginnings to secret missions to being one of America's best resources for new technology, these valleys in East Tennessee have a rich and diverse history. We want to honor those who came before us. We want to keep our place in history alive by revealing the secrets of our hidden past. It was the biggest secret in the biggest war in history. In the early 1940s, thousands of people from all over the United States poured into a quiet farming valley in East Tennessee. And 3 sites mysteriously named Y-12, X-10, and K-25 began work to end the deadliest global conflict in human history, World War II. For the Y-12 site, it all started right here in Building 9731, known at the time as the pilot facility. In March of 1943, the largest magnets in the world were installed here. They were used for a special separation effort to get an isotope that was really needed for the war effort. Calutron is what it was called, and this is the first of many installed here at Y-12. Now, just what is a calutron? Well, it's a mass spectrometer, basically a giant electromagnetic device for separating isotopes. Nobel Prize-winning physicist Ernest Lawrence invented the calutron in California. It's named after the electron magnet cyclotron at the University of California, Cal-U-tron. Here's how it works. A beam of uranium ions passes between the poles of a magnet, causing the ions to bend. They are split into different streams according to their mass, with the heavier ions making a larger arc, and the lighter ones making a slightly smaller arc. The small amount of the rare isotope uranium-235 was separated from the much larger amount of uranium-238 in natural uranium. The calutron worked at the laboratory level, but would it work for large-scale production? To find out, the calutrons here in Building 9731 began running in early 1943. They were used throughout the war to make improvements to the other calutron production units required to separate enough uranium-235 for Little Boy. Lawrence journeyed here many times to check on how well the calutrons were working. On one occasion, he was very helpful, but he caused quite a bit of consternation on the part of one of the scientists here.
We were running one night and very contentedly receiving uranium-235 into the collector pockets, and not a lot of sparking, not a lot of interruption. And E.O. Lawrence came in and he said, "Is this the best that will do?" And he sat down at the controls. And he started adjusting the voltages and adjusting the temperature of the oven to get more uranium out. And he increased that production tremendously. But at the same time, a lot of fireworks were going on inside the vacuum chamber. And in about 5 minutes, everything literally blew up inside the tank.
Lawrence's idea worked very well, even though it caused problems with its first attempt. The improvements were quickly implemented in the production calutrons. Working around the clock, they produced enough uranium-235 to supply the world's first atomic bomb ever used in warfare, Little Boy. It exploded over Hiroshima, Japan on August 6, 1945. Japan surrendered a few days later. With the end of World War II, Y-12's first mission was completed, but there were many more to come.